Hi, this is Eric Sloef and I'm at the breakout sessions and I'm joined by Anne Holler. Anne, welcome.
Hi, thanks.
And Ravi Soundararayan.
Hey, great job.
Okay, first of all I want to congratulate you. You both became principal engineer at VMware and from my understanding that's something really tremendous, enormous, awesome thing.
It's amazing.
Right, right. Are you humbled that they gave you the title?
Yeah, surprised and humbled.
Okay, how are you feeling, Ravi?
The same, surprised and very humbled.
Okay, great. So you are part of the team of Julie Austin, and you are the inventors of the new technologies. And can you elaborate a little bit on virtual machines being aware of the physical hardware they're running on?
So this idea was around making your virtual infrastructure more efficient in the data center. So knowing about power and temperature in your data center so that you can do a better job of managing things more efficiently.
So what you're saying is that a virtual machine is hosted in a vSphere environment, and with HA a server suddenly goes down and you will lose all the virtual machines. But with your idea, the virtual machines are aware that the temperature or the load is becoming too high and they move to another host where it's cooler?
That's right, that's right. Virtual Center would move them to another host where it's cooler, or another host, or to consolidate them more if there's not enough cooling in the data center, for example.
So although all the virtual machines are hosted in a vSphere environment and everything is virtual, we're still running on physical hardware, and it would be nice if we make a vSphere layer aware of what's happening underneath.
Yes, that's exactly the ideas. Yeah.
Okay, so there are already some products that are measuring performance, load, heat, like vCenter operations, and you can also see a lot within a virtual center. What's the difference between your idea and the products that are already existing?
So this idea would just kind of leverage and synergize with those products to do remediation. So those products know there's a temperature problem, or they know that there's a high power load, but this idea would basically act on that information.
So it just signals you there's something wrong, but nothing happens, and your idea is that virtual machines are moved automatically to another host that is much healthier for them.
Yes,
Okay,
right.
So I've heard the story about virtual machines following the moon because they know that it's dark there and and the power is cheaper.
That would be the overall vision. That would be awesome.
Okay,
yes.
Great. Ravi, you had a keynote this morning. You just delivered a session about your idea about combining social media with vSphere environment. Can you tell us something more about that?
Yeah, my basic idea was that in social media we create graphs that illustrate relationships, and we also aggregate and consolidate information so that it's consumable to a human. Why not use that in our virtualization monitoring tools? Instead of bombarding me with a lot of redundant information or a lot of information that's not really relevant to me, try to figure out what's important to me and try to consolidate it so that I can see it in one pane of glass very easily.
So there are all kinds of relationships already within a vSphere environment. You can create affinity and anti-affinity rules in DRS. You can create a host DRS group and a virtual machine DRS group. What is alike from within SocialCast different from an affinity rule in a DRS cluster?
Well, alike actually has a fundamentally different manifestation in this case. When I use the word like, I'm using it in the following way. Imagine a number of hosts are failing because of the same issue. Well, instead of all of them sending you a message saying, I'm failing, I'm failing, I'm failing, I'm failing, one of them sends a message and the rest will like it, and instantly in one easily consumable place, you see the entire reach of the problem. And at least in the implementation we did, when you click a certain place, you can then see exactly which hosts have been affected. Now, likes are good in that sense for consolidating information. What you're talking about is specifying relationships, which we can also do, but we haven't even scratched the surface of how to do that. For example, for now, I'm thinking about VMs related to hosts, related to data centers, etc. But you could easily add networks, data stores, any kind of virtualization entity, and add information like this VM is in a relationship with this other VM, just like what you're describing. Okay. So it's basically leveraging these relationships and simply propagating them in a way that a first-time user of a virtual infrastructure would be able to conceptualize them. Maybe affinity, anti-affinity isn't necessarily intuitive, but friend, not friend, or something to that effect is instantly understandable.
Okay, so you avoid a broadcast of alarms and you are able to pinpoint through these relationships what could be the cause of the problem.
Right.
Okay, great. Congrats again, and many thanks for the interview, Ravi. Great technologies, many thanks.
Thank you so much.
Thank you so much, appreciate it.